Hello and welcome back to the channel. In today's video, I'm going to be showing you some ways by which you can keep track of what is happening on your DB. If somebody changed something on your DB, you will get alerted on your phone. If you get your sync to be your Slack channel, when somebody changes something, you will get a notification on your Slack channel. How is this possible? I'm going to be showing you different ways and different tricks by which you can use it in a production grade environment and how best you can go about it using some technologies that we're going to be discussing shortly. So this is the system architecture we are going to be building today. We are going to start by having some transactions coming into the system, and it could be something like a card transaction, some API, maybe something like PayPal or Stripe somewhere there that we're listening to for events from there. And we can have some customer records, maybe customers signing up into our platform, and something like that can come in. We're going to save this into some Postgres database. You can't use any other relational database or even MongoDB, for instance, if that's what you prefer. But we're going to save this in the database. Then we are going to be connecting that with Debezium. Debezium allows us to capture the changes that are happening on the database level. We're going to ship that through Kafka, which is linked to Apache Kafka, Apache Zookeeper. Apache Zookeeper is the one in charge of the distribution of the controller and the broker that we have on our system. Then we are going to be visualizing the changes that are coming into the Kafka queue with our control center on the UI. Each of these event stream, we can have a drop-in replacement, something like Apache Spark, Flink, Apache Storm, or even KSQL DB connected to Kafka directly, and we can stream this live, and from there we can have a sync of something like Superset, Elasticsearch, Power BI, or Tableau as the final visualization layout. So this is the architecture of the system we are going to be building today, and we are going to be getting started just yet. So let's switch over to the coding section and let's get started. I'm going to start by creating a new project. I'll call this data capture. All right, I'm going to be using Python 3.9. By the way, I'm using PyCharm, just in case you are wondering which IDE I'm using. I'm using PyCharm and I'm using Python 3.9. I'm going to have my main welcome script. We can change that if we want, but we're going to have the main welcome script, and I'm going to click on the create. So we just wait a few seconds for PyCharm to be done with the bootstrapping, and then we can get started. Excellent. Now that the initialization is done, we just clear this out and then we can get started. So we are going to start with the architecture first, where we are going to be setting up the Docker containers that are going to be running on our Docker instance and Docker engine. So we're going to start with Apache Zookeeper, then we connect that with Apache Kafka, and now we can set up the other services that are going to be running on our Docker. So we start with in our terminal. I'm going to just open our terminal in here, and we can start with the Docker Compose. So I'm going to have touch Docker Compose.yaml. Now, in our Docker Compose, we are going to have our services that are going to be running. So I'm going to start with, I'll just reduce this a little bit. So I'm going to start with the Docker Compose version, which is going to be version 3.8. Then I can have my services. Okay, so I'm going to start with the Zookeeper first. So Zookeeper is going to have an image. You can use the Zookeeper, but I'm going to just stick to the Confluent Inc. Apache the CP Zookeeper. Confluent Inc. Zookeeper. I'm going to be using the 7.4.0 version. Okay. Then the host name for our Zookeeper is going to be Zookeeper. The container name is going to be Zookeeper. And we're going to be exposing it on the ports of 2181. 2181 by default to 2181. Okay. So the environment is going to be Zookeeper. I'll just put that in caps. Zookeeper client port, which is going to be 2181, and the Zookeeper tick time is going to be 2000. All right. So because so many services are going to be depending on this, we just need to have an edge check in here. So we are going to do echo server, and then we can have our nc zookeeper 2181 exit 1. So this is going to tell us if the zookeeper is ready to accept connection or not. So retries every 20 times, and the interval is going to be every 10 seconds. So we need to put this on a particular network. So we put this on the networks of right now we don't have any. So I'm going to say the code with you is going to be the name of the network. So let's put the network here. So the network name is going to be code with you, and then the name is going to be code with you, and the driver is going to be bridge. All right, good. So this is the way the network looks like, and we just continue with the service. So zookeeper is ready, and we can start with the broker. So we are going to start with the broker, which is our Kafka. So I'll just paste the broker properties there, and what we're doing in here is to have the Confluent in the CP Kafka image of 7.40. We're using the host name and the container name as broker, and we're exposing these ports. So we're exposing the 29092, 9092, 9101. And these are the environment variables that we're using. So these are going to help us. This is going to help us connect to Zookeeper, and this is the protocol map and the advertised listener. These are the other properties that we're going to be using. In terms of the edge check, we are going to be using this command ncz localhost 9092 exit -1 to have a conversation with this broker to see whether it's up and running and ready to accept connection or not. So once that is done, the next thing we want to do is set up our control center UI, which is where we're going to be visualizing what is coming into Kafka. So we have the control center in here, and we have the CP Enterprise Control Center for 7.40. You don't need this if you can work on the terminal, but for easy interaction with the Kafka topics and the messages, that's why I'm using this. So you don't need this to be candid. So you have the host name, the container name as control center. It only depends on the broker, which is in turn depending on the zookeeper, of course. So we have the ports in here 9021, and these are the environment variables that we are going to be using to connect with the Bootstrap server, which is our broker, the Kafka broker, and the replication factor, the topic partitions by default is 1. The replication factor is also 1. So you can increase this if you want to maybe 2 or 3 or as many as possible that you have the compute for. So you have the network of code with you. The health check is going to be this one, and this we can take for a spin to see whether our control center is up and running, as well as our zookeeper with our broker. So I'm going to do docker compose up detached, and we can see if everything is working as expected. All right, so it looks like everything is created. Let's see if we can see that on the Docker container. So I'll just bring in the Docker container, and we can have our Docker, our data capture in here. So it says this is created, but it's waiting for the broker to be ready before it gets started and fired up. So our broker is still coming up, and while this is going on, we continue with our architecture in the background. So the next one we want to do is the Debezium. So Debezium allows us to do this data capture, the change data capture from the database level. So it goes into the database level log and picks the changes that are happening there and ships it to our Kafka broker. So for the Debezium, we are going to have this, and just here we have the Debezium. It's using the Debezium Connect latest, and it's always restarting. We have the container name and the host name as Debezium. It's dependent on the Postgres, and it could depend on the broker. Then we have our port as 8093, which is where Debezium will be running on. We have the Bootstrap server to connect to our Kafka broker. And we have the advertised host name as Debezium. The group ID is 1. The storage topic is this, and the offset and the status are these ones. The key and value converter, the JSON. In here, we're using the JSON converter, but you can use something like Avro converter if you're going to be using the Avro schema for your key value pair. But I'm going to just stick to JSON in here. So we have the Debezium scripting to enable the scripting level, and this is how to do the else check with Debezium. Maybe I can put this on the same line just to save some lines in here. Okay, and we have it like this. Good. All right, so it starts at the period 10, interval of 10, time of 10, and then retries 10, and it's on the network of code with you. So aside this, we might want to see what is going on the UI for Debezium. So we have the Debezium UI that is sitting here pretty nicely. So we are using the Debezium UI image, the latest image, and it's always restarting. The container name and the host name as usual is Debezium UI, and this is depending on the Debezium. We have the port 8080 where we're going to be accessing Debezium on the UI, and this is where we have the connection to Debezium, which is 8083 as our Debezium. Okay, so lastly, we are going to have our last dependency, which is Postgres. Postgres is like this, and we have the image of Postgres, the container name and host name, and is exposing 5432 on the system. The username and password is Postgres, and we're going to change the database name. The database name we're going to be using is Financial DB. Okay, whatever name you want to call your DB is really up to you. But for the command, we are going to be starting Postgres, and we are going to be setting the world level as logical. This is going to allow Debezium to be able to ship whatever changes that is going on Postgres into our Kafka and be able to read the information that is happening on Postgres. This is how to check for the edge check, and that is all we need to do. So right now, I believe our control center, the broker, and the zookeeper should be up and running. So let's take that for a spin and see if everything is fine before we continue. So I'm going to have this running on localhost 9021. Okay, localhost 9021. And all things being equal, we should be able to see what we have on the control center. Excellent. So we have our the control center, the Confluent control center up and running, and you can see the topics that we have in here. So these are the topics, and most of them are internal. We don't have any topic that is being created right now, and this is what we are going to be focusing on for now. Now, Debezium is also being initiated, but we haven't started that. So let's do a Docker Compose up to start our Debezium as well as Debezium UI to see if everything is working as expected before we continue. All right, so now that Debezium is ready to rock and roll, so let's take it for a spin. So it's on 8080. So let's see what is going on in here. So we can open a new tab and go to localhost 8080. And all well and good, we should be seeing the Debezium UI. And you can see that the Debezium is loading. It's connecting to our Debezium environment, which is the Debezium 8083. And we don't have any connector yet. Excellent. So this is working as expected. Good. Now that the architecture is up and running, the next thing we want to do is we want to start setting up our database, put data into it, and we can see what is going on the database level. So there we can go into our main.py and get in our application started. So we just need to install a few packages. I'm going to install Scicop G2 binary. I'm going to be installing Faker. Right, so the dependencies have been installed correctly. So the next thing we want to do is to take them to work. So the first thing we need to do is import Faker. Then we import Scicop. It's not FK, it's Faker. Okay. Then we import Scicop G2, which is Scicop G2. Now for our Faker, we just say fake is going to be faker.fake. Okay. Now the first function we're going to be creating is the function to generate a simple transaction. So let's say we have generate transaction. Okay. And we have a user with a fake profile. Let's say a simple profile. Okay. So we're going to be returning the transaction. And yeah, so right now we have access to the transaction itself. So the next thing we want to do is where we are going to be putting this in the DB. So let's create a table. So let's say dev create table. If it doesn't exist, so we are going to have a connection from Scicop G2. So we're going to be using a cursor from there. We say cursor. It's going to be connection.cursor, which is not initialized yet, but we are going to be doing that shortly. So we have cursor.execute, and we are going to be executing this set of command. Okay. So we are going to say create table if not exist. We call it transactions. Okay. Now inside this transaction table, we are going to be creating transaction ID as a varchar of 255, and this is going to be the primary key. We are going to have a user ID, maybe in lowercase, as varchar 255. We have a timestamp of timestamp. We have amount is going to be decimal. We have currency of varchar 255. The city is going to be varchar 255. I'll just copy the varchar 255 so I can just use it multiple times. Okay. We have the country. We have the merchant name. We have the payment method. Don't need double comma. We have the IP address. We have the voucher code, and we have the affiliate ID, and then that's it. So this is the code we are going to be using to create our table if it doesn't exist before. And at the end of the day, we just close the cursor, close, and then connection.commit. Good. Now we have our table created for us. So the next thing we want to do is take this for a spin, connect to the DB, and let's say insert the transaction into this table. So if the name of the, let's create an entry point here. If the name equals to name, you can have connection is going to be psycop g2.connect. So we are connecting to the host, which is going to be localhost. We have the database, it's going to be financial DB. We have the user, it's going to be, say, Postgres, and the password is going to be Postgres. Then finally, we have the port, which is 5432. And where am I getting all of this from? If you look at our Docker Compose and you look at our Postgres, we have the username, password, and the Postgres DB is financial DB. And that's where I'm getting that from. The IP address, the port rather, is 5432. Okay. Now, once that is done, we've established connection to the database. The next thing is to create a table. We're going to be using that connection that we brought in from here, and we are passing that into the table. So by now we have a table created in the DB, and from there we can create a transaction. Transaction is going to be generate transaction, and we can just create a cursor in here. It's going to be connection.cursor. And if we want, we can see how the transaction look like. Transaction. Then we create an insertion. We write our insertion query in here. So we are going to have the cursor.execute, just like we had before, like this. We can say insert into transactions, and we just get in the names of the columns, which is transaction ID. We have the user ID. Here we have the timestamp. We have the amount. We have the currency. We have the city. We have the country. We have the merchant name. We have the payment method, as well as the IP. I'll just put this here like that. We have the IP address. We have the affiliate ID, and we have the voucher code. Okay, then the values of what we're going to be inserting is going to be percentage %s. This is 1 2 3 4 5 6 7 8 9 10 11 12. So we need percentage %s in 12 places. So this is 1 2 3 4 5 6 7 8 9 10 11 12. So we just need to bring in the values, and at the end of this, using 3 quotes, I'm going to just have in a tuple of all the transactions that I'm going to be inserting into the DB. So I'm going to start with the transaction, and I'm going to bring in the transaction ID. Then I'll just copy this so I can just be pasting it multiple times. Then I have the user ID, the timestamp, so I can just say timestamp in here, but I'm envisaging some challenges with this, which we'll get to shortly. And I'm going to have transaction, the amount, and then the category, the currency, we have the city, we have the country, we have the merchant's name, isn't it? Merchant's name. We have the payment method. We have the IP address. We have the affiliate ID. As well as the voucher code. Okay. Now these are the transactions. So at the end of the day, we just need to close this entire bracket for this our query, and we just cursor.close and then connection.commit. And this hopefully should be able to get our connection established to the database, create a table, and just insert this particular data into the DB. So I'm just going to click on this to run. And it says module faker. That's nothing like fake. So what is going on? And we have faker. So instead of fake, it should be faker. I'll just rerun that. And we have an error. So the error is saying transaction ID. It says, what's the error? Key error of transaction underscore ID. So there is nothing like transaction underscore ID. It's transaction ID. So I'll rerun this. And lovely. So we have the payment payment underscore method. It's not supposed to be payment. A typo there. And I'll run this. Okay, so we have the affiliate ID, affiliate underscore ID, which is what we have in here. I don't know why I changed the name, so it should be affiliate ID. I'll just copy this and use it in here. It should be underscore. So for uniformity's sake, but for some reasons I forgot to, that was a typo there. Now there's an error in here. So we have this cyclope data type mismatch. The column timestamp is of timestamp without a time zone, but the expression is of type numeric. So let's fix this. And this is what I was expecting, because timestamp that is coming in from our faker is going to be representing this in this one. Where's the timestamp? This one is going to be representing it in number. Okay, something like this. So let's fix that and fix the error with the timestamp. So basically what we want to do is we want to extract the timestamp from here and convert that to date. So we say date time dot from timestamp, which we have this timestamp that we have in here from timestamp. Then we now convert it to the formats that we want. So I'm going to just bring this here. Okay, and the timestamp is going to be formatted with strf time, and I'm going to have the year percentage year, the month percentage m, then the day is percentage d, and not only that, I just need the hours, minutes and seconds, HMS. Okay, hours, minutes and seconds. Okay, and this should fix it. So I have the year, month, day, hours, minutes, and seconds. So lovely. So I just need to rerun this and let's see if everything is fine. Excellent. So we are able to insert data into the DB without any error. So let's double check that. I'll just clear this. Yeah. And Docker exec, IT into Postgres. So we just go into Postgres using the exec command, the interactive terminal, the container name, and the maybe bin bash as our code. Okay, so I'm going to be connecting to the PSQL. The user is going to be Postgres, and I'm going to be connecting to the database of financial underscore DB. Okay, lovely. So I have access to this. Now let's see if we have the databases initialized already. So we have the public, the tables. So we have the public and we have transactions in here. So if I do select start from transactions here, and you can see that I have the data sitting here pretty nicely, and this is how it looks. I'm going to show you the two ways that we're going to be using to create a connection to Debezium. So the first one is going to be on the UI, which is this UI that you see in here, and the second part is on the terminal, where we just create it. We have a JSON and then we just pass it into the connector API, and we can create our connector from there. So let's continue. So in here, we have the connectors. I'm just going to click on create connector, and it's going to ask us which type of connector we want to create. So I'm going to be selecting Postgres as our connector in here. So once I select Postgres, I click on next. The connector name, I'll call this financial, maybe Postgres financial connector. Maybe I'll just use dash. Okay, Postgres financial connector. The prefix is something to prefix our table that we're going to be monitoring. So I'll just call it CDC. The host name is Postgres. The username is Postgres as well. We have the password as Postgres. The database name is financial underscore DB. Then in the advanced section, we are not connecting with SSL, but if we are, this is where you pass in the required parameters. And in the replication, we are using the decoder above. So I'm going to change that to PG output, leaving slots as it is with try count and the rest like that. So let's validate the connection if we are able to connect. So we are able to validate and connect to Postgres. So at this point, we have access to the DB, and you can see that we have transactions sitting on the database in here. So I just click on review and finish, and you can see the JSON that is generated for us. So this JSON is going to be used to create a connector for us. So I'll just maybe copy this and finish. Now you can see the Postgres thing connector is of status of running, and the task here is running. So you can see the details of this connector in here. These are the properties that it is using in here, and this is the JSON view of how the connector look like. So if you want to create a connector, you can do the same in here by copying this JSON and passing it to the API to create a connector. But before we go, let's see if we are able to successfully replicate whatever is inside our database on our Kafka broker. So coming back in here, if you look at the Postgres instance in here, you can see that we have something going on in the logs here. So we have the log in here. You can see there are currently no running transactions, and it's now creating a replication slot for Debezium using the PG output. And from there, you can see each of the steps that is created, and at the end of the day, it starts a replication slot. Now, this means at this point that we've been able to successfully create a replication directly from Postgres into Debezium. So whatever Debezium used this for is now left to it. And let's see on the UI, on the local host in here. So I'll just go to this cluster. And in the topics, I don't have any topic right now. And let's see if we are able to. Yeah, you can see cdc.public.transactions in here. So if I click on the public and I click on the messages, and I go to the initial offset, the earliest offset of 0, partition 0, just run this, and you can see the data that we passed into our DB. This is the structure of the database, the way it looks like, and these are the fields: the transaction ID, user ID, the timestamp, and the rest, right? And in terms of the value, if you look at here, you see the payload. Here we see the before, because there's nothing before, and the after, which is this the latest information in here. So if you look at the amount that we have in here, the amount is not represented as a number or decimal, because that is not what we have. If you look at the amount we have in here, we have 575.82 as our amount. And we are seeing scale of 2 AODU in here. So this is the first thing we need to undo first. And aside this, it looks like we don't have any value before, which could be valid. But let's see if we change something and if everything is fine as expected, so we can fix whatever issue is at once. So I'm going to just try and update this particular amount, and I'll just increase it. I'll increase the value by some number. So I'll say update transactions. The set the amount equals to amount plus 100, where the ID equals to I'll just delete this, where the ID equals to this. Not the ID, is transaction underscore ID. I'll just close that, and you can see update 1. So if you go back in here and we click on the play again, you see the next record in here that just came in, and in the field section you still see before. Now this is a problem, and the reason is because we don't have the value for before, the value of the data that is coming in before the update. We only have the after. So what happens before? We don't have that. So let's fix that particular problem. So the problem is coming in. If we go back to the terminal, even though we set our while logical to be true, we still need to fix that particular changes before and after. And the way to do that is to come into the terminal. In here, we have the alter table, and we can have public dot the table name. I don't need public. I just transactions. I just need to have the replica identity full. Now this way, if I run this, any changes that is happening on the DB level is going to be replicated in terms of the before and the after on this particular transaction table. So let's take that for a spin and test it out. So in here, I'm just going to update the transaction again and increase the value from 100 to maybe 150, for instance. Okay, and I run this. We have an update, and on our Kafka, if we come back in here, we have a new record. And if you look at this in the payload section, I'll just minimize the fields, and you can see the before. Now the before amount is fine, but after amount, you can see the value, but the amount is still not fixed. So let's fix the amount. Now, the reason why the amount is not being represented as a single digit is because of the way Debezium handles the decimal values. Decimal values that are being consumed from Postgres is being converted to a more logical value on Debezium. So to be able to see that and be able to relate with what we are seeing on Debezium, we need to change the connector value so that we can easily just see whatever the amount is and in decimal, and be able to see it without having to do any conversion. So let's fix that. So the way to do that is to come back to the terminal in here. So you can do that by coming here and, in the custom properties, you can undo that in the custom properties, but I'm not going to be doing that here. I'll just use the same API level to fix that. So let's run this on the API level. So I'll just open a new terminal here, and everything we have in this JSON that we had here, this JSON, will be replicated with the exception of the name. So I'm just going to get the name out of here. So I'll just maybe do the same thing here on the terminal. So I'll just say call, and I'll just add a new record or a new property here. I'll call the property name decimal.handling.mode, and I'll pass in it as a string. And that's the only thing that I need to do at that point. So the only thing that I need to fix here is going to be the name. I'm going to be connecting to localhost. So I just need to change this to localhost, and I run this. So it says couldn't connect to 8083. Did we expose that on our Docker? No. Okay, so I'll just copy this. No problem. I'll just copy this. Okay, I'll just copy this. And in my Debezium in here, in Debezium, I'll just, on the execution section here, I'll just paste the same code here and I'll run. And it says unexpected character. And the character is what? Config. So yeah, let's fix that. Whatever the error is, I'll just put that here. I'll just paste everything straight, expecting comma to separate object entries. So there is no comma between my topic prefix and the transactions in here. So I just need to add a comma, and I run this. And lovely. So you can see that we have this running as expected. And if you look at on the UI, you can see my new Postgres connector. So I can delete this old one, and let's close this one. I'll just delete the old one. Postgres thing. I'll just delete this, and I'll just leave it as a Postgres connector. And you can see the new property that I added in here, which is the what's the name? Database decimal handling. This one, decimal handling mode. I'm using the string as my decimal handling mode. Now, so any record that is going to be produced to this database now is going to be in the same, instead of that number, you're going to see a string here. So that should fix that for us. And then by the time you want to consume this, you need to format this in the right shape before using it. Okay. So, right. So let's fix that. Now the new records are being inserted. So let's go back and see if we can insert new records and try to update them. Now that we've fixed all of the issues there, I'll just clear this up and change my theme back to dark. Okay. Okay, so now we have been able to ship data into Kafka. We just need to ensure that it is working as expected by running this again. I just need to run this again, and we should see a new record being inserted in here. And you can see the new record here, and we have the fields. Before it's still null, which is fine because it's a new record. And let's try and update this particular transaction ID. I'll just copy this transaction ID and go into my Postgres here. In the terminal, I'll just, okay, I think I had one terminal open here. Yes, I have this, so I can just do the same in here, but with a different ID. So I can have an ID here and run this. So I'm increasing the amount by 150. The previous amount we had was 364. So if we had 150 to this, we are expecting something like 500 and 511 or something like that. So let's see what we have. I have this record here, and I have the before is 364, and I have 514. Good. So That is the new value. And based on this, I can now have, maybe I want to have Apache Flink or Apache Spark or any other UI. So at this point, we are done with the connection between Postgres and Kafka using the Debezium. So we have been able to establish a connection to Zookeeper and our control center. So this entire section is being handled. At this point, we have access to the DB. We've been able to change whatever record on the DB and it's being tracked by Debezium. But we still don't know who changed this data and when was it changed. So let's fix that so that we can know who changed it and when, so we can ensure accuracy and transparency. So we can also have some level of accountability to know who changed this, when the account was logged into probably, and then, at what time it was changed. So let's do that. So in the DB, so for us to fix this part of this, if you look at what we have on this database, on this table, in this transactions table, we are ending at affiliate ID regardless, but we don't have whatever column that is tracking these particular changes on the DB. So let's fix that particular change. Okay. So the first thing we want to do is we just do an alter. So to add new column, so alter table transactions. Okay, add column. So we are adding a new column. The column name is going to be modified by, and it's going to be a text field. And we also add one more, and modified, that will be modified at, and this will be timestamp. These two are going to help us keep track of who changed whatever record in the DB and when it was changed. So let's fix that. So we are going to have two layers. So the first one is in insert layer, which we don't really care so much about what has changed as at that point, because we know that the record is going to be created regardless. But it is at the point of the update that we're going to be keeping track of what is happening there. So we are not going to be focusing on the insertion layer, rather on the update layer. So let's fix that. On the update layer, we are going to have a simple function that is going to help us fix this. So the first function is going to be create or replace a function. So the function is going to be a record change user. So whoever changed this data is going to come in, and then we're going to have record change user, and so this is going to be returning a trigger. And as this is the function to create a trigger that is going to be doing this. So in the begin section, we are going to have the new, and then the modified by is going to be assigned to the current user. And this is going to be the user that is logged into the system. Okay, and the next one is going to be the modified at. So new dot modified at, and this is going to be assigned to the current timestamp. The current timestamp. Then the last thing we would just need to do, once we've assigned the modified at and the modified by, we just return new. Okay, then we end this. Finally, we just specify the language if we want. So the language is going to be PLPGSQL. Okay, and it says return trigger as is incorrect. So let's see, it's not supposed to be return, it should be returns. Yeah, that's an error on my part. So the function has been created as of this moment. Right now, we just have the function, but it is not being tracked on any of the tables that we want to associate this particular function to. So we just need to pick this function and say, track it, track using this function, track whatever changes that is happening on this particular table. So let's do that. So on this table that we have a transaction table. Okay, so let's do an association with our update on the transaction table. So we're going to have create a trigger, and the trigger is going to be trigger record user update. Okay, so before updates on transactions, okay, for each of the row, I'm going to be executing this particular function, and the function is going to be record change user. Okay, so again, if I run this, now the trigger is created, and you can see that we have create trigger. For this is the trigger name. So we are saying before you update any particular record on transaction, execute this particular function and use that value, whatever it is in this function on this particular transaction table. So let's test this out. So in our update, we had an update in here, and if you can recall, in our the previous value we had here for the latest value, the latest record in here is having let's minimize this field. The before is 364 and the new record is 514, right? So we are expecting that if we add 100 to this, we are going to have 60, right? So let's put 100. So we have 614 on that particular transaction. So let's see if we are able to capture who changed what and when it was changed. So we can do select star from transactions. Okay, and if I run this, it has two rows, so you can see this particular modified by and modified at. You can see the values here, and if you come to our um our, our events on our Kafka, in the topic here, you can see that we have on the fields, I'll just minimize this. In the payload, we have 514 before, and after you have 614. This is good. Now, one last thing is we just tracked what is happening on the entire column, but we haven't been able to track what exactly was changed. If there are so many columns, we can have them side by side and keep checking one after the other what is changed, or we can even have that in a particular column to see this particular column was changed and this is the old value and this is the new value, more like a JSON record as at that point. Okay, so let's do that before we proceed. So in our DB, we can have something like this. So let's drop this particular trigger that we just created and on this particular table. So this is the trigger name. I'll just say copy this, drop trigger on transaction. Okay, so I just no, it's transactions. Okay, so now this trigger has been dropped. So let's create a function that is going to now keep record of the old, of the old record and the new record. Okay, so the way we do that. Oh, by the way, if we just keep track of the entire record, okay, that is going to give us a very huge JSON object. But if you want to, limit it to a particular change that is happening on the DB, we can do that by just, keeping a check of the old value and the new value on the SQL, and the changes that are happening there, we're going to be inserting that into the DB, into our event stream rather. Okay, so let's do that. So I'm going to have create or replace function, and the function is going to be the record changed columns. Okay, so this is going to be returns trigger as dollar 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 dollar. Now let's declare the way the JSON is going to be looking like. So I'm declaring change details JSON B, and then let's begin. So at this point, this is where we are going to be creating our JSON with the old value and the new value. So let's say we have change details is going to be equals to a JSON object, which is going to be interfacing with a JSON B. That's the empty JSON object. So potentially this is a empty JSON object, just like you have in your Python or any other language, right? So now let's double check this. If the new value, new dot amount, we want to keep track of the amount column. Okay, if the amount is distinct from old dot amount, then I want to put in the change details. Change details is going to be equals to JSON B insert. So in the change details column, I'm going to be putting the amount as this, as a curly brace, okay? And the JSON B, I'll build an object from that, build object. Then the old value is going to be old dot amount, okay? And then the new value, new, is going to be new dot amount. And I'll just close this. Now, end if. Okay, so now at this point, this code is going to help us keep track of the changes in the amount column itself. But we also need to add in who changed it and what time it was changed. That hasn't been handled yet, so let's handle it. So the second part is we are going to be adding the user and the timestamp. The timestamp, okay? So I'm going to say the change details is going to be equals to change details in concatenation with JSON B object. JSON B build object, okay? And I'm going to have modified by, then the current user, just like we tracked earlier, and then the modified at is going to be, now, this is the time it was changed. Good. Now, finally, we just say update the change information column, which we don't have right now. So change info column. So we just say new dot change info column is going to be assigned to change details, just like that. Change underscore details. So I just return new and end, and then the language is going to be language. I think I just missed out on, yeah, there's a semicolon that I'm missing there. Language is going to be PL, PG, SQL. Okay. So let's fix that. Yeah, in here. So I have end. I just need to put a semicolon there, semicolon at the end there. And do we have any other ones that we haven't added semicolon to? If I run this, it says syntax error in line 8, new dot amount is distinct from dot amount. So let's go there. So at the end of our JSON B, before the if statement, I didn't add a semicolon. Okay, so I just need to add a semicolon here. And I think we should be good. Is it? Yeah, I think we should be good. If I run this, excellent. So now we have this particular function that is created for us. Now, we just need to associate this particular function with the table itself, which we just did, but let's associate it with that particular, because it's returning a particular trigger, right? So for us to associate that, let's add this particular column that is going to be our JSON B column, okay? So I'll just say alter table transactions. I'm going to be adding column. The column name is going to be change info column, and the type is going to be JSON-B. Okay, if I run this, that is fine. Now, let's create this particular trigger that is going to be triggering on update, just like we did before. On update is going to be triggering this particular function. Okay, so if I do select star from transactions as of this moment, you see that we have a new column called change info. So let's add that function, that trigger. So I say create trigger, and I'll say trigger record change information. Okay, now before the update on these particular transactions, for each of the row, execute function, and the name of the function that we just created is this. What's the function name? Record change columns. So I'll just paste this in here, and I'll call the function, and I add a semicolon, and boom. Okay, not reach for each. Okay, boom. So the trigger has been created now. So let's try and change something and see the difference of what is going on in the DB. So select star from transactions. We have this. So let's insert a new record in there. Good, a new record has been inserted. And in the terminal, if I run this again, you see a new record. So let's copy this particular transaction ID, the last one in here for Catherine Hill. I'll just copy this and I say update. In fact, I think I already have an update statement written before. So let's use that. Yeah, this one. I'll just change the transaction ID to this, and I'll change the amount to, let's say 1,000. 1,000. And boom, if I run this, if I do a select star again, you'll see in the change info column, you see the amount, which is the new 1,000, and the old was 202.68, and it was modified at this particular time by a user called Postgres. So let's see how it looks like on our Kafka topic. So if you come back in here in the offset 8, and I scroll down in here, I drill down into that, minimize the fields. Before, Catherine Hill had £200 in her account, and the modified art buyer and change info are null. But at the end of the day, you see that Catherine Hill has £1,000. The modified buy and modified art was not captured, but we have a change info at this point, which is the new is 1,000, the old is 202.68. Modified art is this, and modified by is this. So if you want to update these two guys also, instead of just putting that inside the function as a JSON object, just like we did in here, instead of putting it in as a JSON object here, just like this, you can do the same new dot modified by new dot modified art, just like we did earlier. So this is how to do the update and the insertion, and you can capture the exact column that is being changed by any particular user in the DB. But a caveat here though, it takes some time. If you want to capture many columns or multiple columns, you can do that, but you have to individually check for each of the values, for old value and the new value. You compare them. If there's a difference, then you add the record to the maybe change info column, if that's what you wish to call your particular column name. But that's how to keep track of a particular column changes and get that changes into a particular column that you want. So in the next video, we are going to be proceeding and building on this particular section. Once the data gets into Kafka, what happens next? How do we proceed from there? You can build a streaming layer on top of that, maybe with Apache Kafka, Apache Flink, or something like Apache Spark, or you can even use something like maybe any of these architecture that we had, just like we have Spark, Flake, Apache Storm, or you can even use KSQL DB to do your transformation layer into another stream or into a table that you want. And then based on that, you can build a UI or visualization to keep track of what has been going on over time by each user, what time they are logging in to change something or something like that. And that can give you some insight into what is going on really. So this is where we are going to be putting a stop to this particular section. So join me in the next session for the next video, and we can build on this from that video. If you have not subscribed to the channel, kindly click on the subscribe button, like and share. If you have any comment or feedback, drop them in the comment section. Thank you for watching, and I'll see you in the next one.